So Greg, we were just talking earlier about the new PIC 16 family and the ability to drive and inductive cooktop.
Yeah, so here, this is our inductive cooktop example that we have out here at the show today. Again, it's working on our PIC 16 F 1708 product family.
1708.
It uses the, so you can see the back, here's the inductive coil here. We have a temperature gauge coming back to the device, so with the ADD we measure the temperature. We also measure a current and over voltage situation with the same ADD. We also have two fast comparators that are actually doing the zero cross functionality on the coil rather than using the zero cross, which is kind of interesting, but we're using the zero cross for traditionally non-traditional function.
Okay.
So zero crosses are typically used for triacs or driving relays. Right. In this instance, we're actually using the zero cross detect as a real-time clock.
Right.
So we're measuring the 60 hertz coming off the AC line and using that as a clock frequency to count up and then go do safety check after a certain time. So we're feeding the output of the zero cross detect into a counter, doing a count, and then going back and doing a safety check on our devices. So a little bit different use for a zero cross detect, but the module's there, it's easy to use, it's a reliable source for our clock.
So let's talk about that for just a moment.
Yes.
That requires less coding doing it that way because you're doing it using one of the external modules. Why is that a good thing?
So that's a good thing in a couple ways. One, if this would be a particular safety critical application where I had to do through Class B or UL, since I'm doing it all in hardware, I don't have to go back and do CRC checks on my code. So it saves me time on my computation time, it saves me code from writing the code to actually do that function, and it saves me overall power consumption as well, because I'm doing it all in hardware and I'm not turning the core on to go do that type of functionality.
Okay, that explains it. Are we likely to see a PIC 16F and the rest of the family in an application like this sometime soon in white goods?
Absolutely, yes.
We are?
Yes.
Are they currently out there today?
They're not out there today. The product just released as of yesterday, so we are working on designs to get that, but yes, we do absolutely see these kind of applications in our pipelines.
So we've got the board. Tell me what we're looking at, please.
So Chris, what we're looking at here is the board that actually is in our inductive cooktop reference design. As compared to a typical inductive cooktop board, what you'd see on here is probably 30% more product. So we've reduced the overall component count down by 30% with the integration of our analog peripherals on this device. We estimate that's about $1 worth of BOM compared to the existing boards that are in the market today.
So we're not looking at a lot of analog components on this board then?
No, again, all that has been sucked into the PIC Micro itself. So what that does is saves the customer board space as well as BOM cost.
Awesome. Greg, it's been a pleasure. Thank you.
Thank you.
Chris Ciufo coming to you with Greg, Microchip from EE Live 2014, formerly known as ESC. Thank you.
Thanks.